Okay, in the morning session, we left one topic called Hamming code. We'll solve the problem, right? What is Hamming code? So, Hamming code is for error correction. Hamming code is for error correcting. Error correcting code. Hamming code is an error correcting code. So, for example, we need to take a data word like 100, 111, 000, 1. For example, if it is a data word, so what you have to do with the help of Hamming code. Remember this code. Maybe any code, not a problem. Might be 11, 00, 111, 000, 1. If it is a code, okay, this is a data word. How can we solve this problem? Using Hamming code. So with the help of first we need to note down the numbers like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14. After that, what you need to do? So in the powers of two positions, you need to keep the parity bits. 2 power 0, 1, 2 power 1, and then 2 square, and then 2 cube. 2 power 4 is 16. Okay, like that you need to keep the parity bits. After that, what you need to do? From in this direction, you need to write the numbers: 1, 0, 0, 0, 1, 1, 1, 00, 11. That means there is no 16th bit for this data word. So 11, 00, 111, 000, 1. So like this order you need to note it down, right? After that, what you need to do? You need to calculate the values for P1, P2, P4, and P8. So how can we calculate? So for P1, you need to consider the positions like 1. You need to consider 1 and you need to leave one position. 3. Consider one position, leave one position. Consider one position, leave one position. Like that you need to consider 1, leave 2. Consider 3, leave 4. Consider 5, leave 6. Consider 7, leave, consider 7, leave, leave 8. Consider 10, 9, leave 10. Like that, you need to note it down up to 15 positions. Why? Because we have only 15 positions. So you are calculating for P1, right? So for that purpose, you need to discard 1, and from these particular positions you note it down the values. What is the value of 3? At 3 we have 1, at 5 0, 7th position is 0, 9th position 1, 11th position 1, 13 0, and then 15 1. Check once again: 3 1, 5 0, 7 0, 9 1, 11 1, 13 0, 15 1. Like that we need to consider one position and leave one position. You need to start from 1. Why? Because we are calculating for P1. So 1, we need to leave 2, 3, 5, 7, 9, 11, 13, 15. And then how many number of ones are there? There are 4 number of ones. That means even. So the P1 value is 0. Why? Because the number of ones are even. Even parity. Okay. And then calculate for P2. So we need to start from 2. Why? Because we are calculating from 2. Parity 2. So we need to consider 2, 3, 2 positions, and we need to leave 2 positions, 4, 5. And then 6, 7. You need to leave 8, 9. And then 10, 11. 12, 13. You need to leave 14, 15. 2, 3 consider, 4, 5 leave. 6, 7 consider, 8, 9 leave. 10, 11 consider, 12, 13 leave. 14, 15. Okay. So we need to discard second position and then write down the values: 1, 3, 6, 0, and then 7, 0, and then 10 1, 11 1, and then 14 1, 15 1. So number of ones 1, 2, 3, 4, 5. So odd number of ones, so we parity is 1. We need to make them even. 1, 2, 3, 4, 5. 5 is odd number, so we need to make them even. So parity bit is 1. And then you need to calculate for P4. Okay, 4, 5, 6, 7. You need to consider 8, 9, 10, 11. You need to leave. Consider 4, leave 4. So 8, 9, 10, 11. You need to leave. 12, 13, 14, 15. So 4, 5, 6, 7 you need to consider. 8, 9, 10, 11 you need to leave. Again 12, 13, 14, 15. So what are the values we need to discard fourth position? 0, 6, 0, 7, 0, 12th position 0, 13th position 0, 14, 1, 15, 1. So the value is 1, 0. Sorry. Why? Because number of ones are 2, the value is 0. And then P8. 8, 9, 10, 11, 12, 13, 14, 15. You need to consider 8 positions and you need to leave the 8 position. Here we have only up to 15. Okay. So 8, 9, 10, 11, 12, 13, 14, 15. 8 positions we need to consider as we are calculating for P8. Okay. So we need to discard the 8th position and from 9, 1, 1, 1, 0, 0, 1, 1. How many number of ones? 1, 2, 3, 4, 5. So odd number of ones, 5 number of ones. So we need to add 1. So these are the parity positions at the center. Okay. After that, what you need to do? You need to send the data to the receiver. At the receiver side also, you need to calculate for P1, P2, P4, P8. Okay. If there is no transmission error, then as it is these values will come. P1 0, P2 1, P4 0, P8 1. The same values will appear here if there is no transmission error. For example, I want to change this 1 bit to 0. That means while transmitting the data, it will be changed to 0. So how can we detect and how can we correct using the Hamming code? Okay. Again for P1, what are the values? 1, 3, 5, 7, 9, 11, 13, 15. So discard P1 and next P3. 1, 0, 0. 9 is changed to 0. 1, 0, 1. So how many number of ones are there? 1, 2, 3. So we need to make them even. And next coming to P2, 2, 3, 6, 7, 10, 11, 14, 15. So what are the values we need to discard this one? 1, 0, 0, 1, 1, 1, 1. So how many number of ones are there? 5 ones. We need to make them even. And then for P4, 4, 5, 6, 7, we need to do 8, 9, 10, 11. So 12, 13, 14, 15. So discard 4. So 0, 0, 0, 0, 0, 1, 1. So the number of ones are even. So the parity bit is 0. 8, 9, 10, 11, 12, 13, 14, 15. Discard 8. So ninth value is changed to 0. So 1, 1, 0, 0, 1, 1. So how many number of ones are there? 4 ones. So the parity is 0. So what are the center side parity bits? Center side parity bit positions. 0, 1, 0, 1. 0, 1, 0, 1. What are the receiver side parity bits? 1, 1, 0, 0. 1, 1, 0, 0. In which position there is a change? In the P1 position, there is a change. Here the value of P1 is 1 at the center side. At the receiver side, the value of P1 is 1. And at P4, sorry, P8, this one. At P8 also change. P1, P2, P4, P8. So the P8 also changed to 1 to 0. So the position P1 and P8, there was a change. So if we add 1 plus 8, it is 9. So ninth position, the value is changed to 0. So you know the location where the data was changed. So we can replace it to 1. Like that we can correct the errors. Okay. Only we can correct the single bit errors. We cannot correct the 2-bit errors. For example, if 6 also changed to 1. For example, 9th bit position and 6th bit position. Both are changed. If both are changed, na, where is the sixth value? 1. 1. So 1, 2, 3, 4, 5, 6. So parity is 0. And then 1, 2, 3. So odd number of ones 1. So automatically 1, 0, 1, 0. If it is 1, 0, 1, 0, then here P1 is changed, P2 is changed, P4 is changed, P8 is changed. All are changed, right? So that means we cannot all we will get the values like 1, 1, 1, 1. There are 4 changes. P1 position change and P2 position there is a change and P4 position there is a change and P8 position there is a change. So all positions are changed. That we can detect that there is an error. We can detect that there is a transmission error, but we cannot correct it. That means Hamming code is used for Hamming code is for detecting single or burst error. It may be a single error or it may be a burst error. It can detect the error, but it can only correct single bit errors. That is about Hamming code. Okay. Right. In the morning class, we have covered so many concepts under medium access control. Now we are in the wireless LAN protocol. Okay. So we are in the MAC. MAC means medium access control. So under the medium access control, we have covered static allocation, problem and dynamic allocation. And then we have covered some protocols, random access protocols like Aloha. In Aloha, we have covered pure Aloha. And then we have covered slotted Aloha. And then under the CSMA, we have covered one persistent, non-persistent, and then P persistent. After that, we have discussed about CSMA by CD, and then we have discussed about collision-free protocols. So under the collision-free protocols, we have bitmap, and then binary countdown we have covered. So now we are going to discuss about the topics leftover the topic in the MAC. What is the leftover topic in the MAC? That is wireless protocol. What is problem with wireless LAN protocols? What is the problem with wireless LAN protocol? So I will let you know one thing. Wireless LAN means there is no wire between the communication parties. There is no cable between the communication parties. So what is the problem first? So what is for wireless LAN protocol? What is the problem in wireless LAN? So let me explain you with an example. For example, this is a mobile device A and it is the device B. Sorry, same distance we need to take. Right, and it is the C. So these are the devices, right? So what is the transmission range of this particular device? A's transmission range is up to B. And what is the transmission range of C? C's transmission range is up to B. That means A can send the information to B and C also can send the information to B. The transmission range of A is up to B. And the transmission range of C is also up to B. Okay. And next, what is the transmission range of B? The transmission range of B is, this is the transmission range of B. So now at one point A and C both are willing to, A and C both are willing to transmit the data. Both are willing to transmit the data to B. Okay. So A is hidden to A. What is the problem here? A is hidden to C and C is also hidden to B. Why? Because in the A's transmission range only B is there. In the C's transmission range only B is there. So A is not known to C and C is not known to A. So but both A and C are willing to transmit the data to B at the same time. At what happened? So both are sending the data to B at the same time. So collision is happened. Collision is happened at B. Okay. Why? Because A is hidden to C and C is hidden to B. So this is the problem. How can we solve this hidden problem? Okay. This is one problem. And then the second, this is the first problem, hidden problem. And what is the next problem? For example, this is A. With the same diagram, you can, we can, right? For example, now B is willing to transmit the data to A. This is the first one, first case. What is the second case? B is willing to transmit the data to A and C is willing to transmit the data to the some other node D. Okay. So whenever the C is willing to transmit the data to D and next B is willing to transmit the data to A. A is of this side and D is of this side, right? But C is exposed because of B. Why? Because B is in the transmission range of C. So whenever C is trying to transmit the data, C might think that, so my transmission range D is there, B is doing some transaction. So some information B is willing to transfer some information. Okay, that is the reason why C is don't want to send the information to D, because if I send some information, it may be collided with the B's information. That is the thinking of C. But B is transmitting the information to the some other node which is available in this direction. C is willing to transfer the data to the D which is in another direction. So but C is don't want to send the information to D because B is doing some information transfer. So unnecessarily C is waiting for the B's information transfer. Okay. So because of that reason, C is not transferring anything to D. That is called as C is exposed. C is exposed to D. ఓకేనా బి వేరే డైరెక్షన్లో ఉన్న నోడ్కి డేటా ట్రాన్స్ఫర్ చేయాలనుకుంది బట్ సి డికి ట్రాన్స్ఫర్ చేయాలనుకుంది సి అన్నెసరీగా వెయిట్ చేస్తుంది అనమాట బి ఇన్ఫర్మేషన్ షేర్ చేస్తుంది కాబట్టి సో దట్ ఈస్ ద ప్రాబ్లమ్ ఎక్స్పోజ్డ్ ప్రాబ్లమ్ హౌ కెన్ వీ సాల్వ్ దిస్ హిడెన్ అండ్ ఎక్స్పోజ్డ్ ప్రాబ్లమ్ రైట్ for the first case is both A and C willing to transfer data to B. So the collision is happened at B because A is hidden to B, C and C is hidden to A. That is the first problem. And the second problem is B is willing to transfer data to A and next C is willing to transfer data to D. But C is waiting for B, waiting for B. C is waiting until B completes its transfer. So no need to wait for the B's information transfer. Why? Because C is willing to transmit the data in this direction. But C is waiting unnecessarily. That is the exposure problem. So how can we solve these problems? So A, B and C. Whenever a node want to transmit the data, the node need to send the broadcast. The node need to broadcast RTS. What is RTS? Request to send. So whenever A and C are willing to transmit the data to B, First of all, A and C are need to transmit the request to. Sorry. Whenever whenever a node is willing to transmit the information to other node, so they what they need to do, they need to send a request, that is called as request to send. So what is request to send? So what it contains? It contains the sender address, the receiver address, and then time required for transmitting the data, and how much time they need to communicate with that particular node. Here the sender address is A and the receiver address is B, and the time is 10 milliseconds, for example, communication time. And here C is also willing to transmit the data to B. The sender address here is, with respect to C, the sender address is C and the receiver address is B, and then length of communication time, for example 15 milliseconds. So what the B will do? So B can send a reply to the nodes. So what it contains? It send a CTS. It send CTS to these two. What is CTS? CTS means clear to send. Okay, clear to send means what it contains. It is also contain the sender address and the receiver address and the time, 10 milliseconds. So obviously B is willing to communicate with A. For example, B is willing to communicate with A. So in the B's CTS, what will be the source address? Source address is A. Why? Because A is requesting B. I want to send something. So B accepting the request of A. So the sender address is A and the receiver address is B, and the time of communication is 10 milliseconds. So that, one second. Okay, sorry for the inconvenience made. I got a call. Right here, what happened? So the CTS contains who is the sender. The sender address is A, and who is the receiver? B is the receiver, right? B. And what is the duration of the communication? 10 milliseconds. So the CTS will be delivered to both C and A. Why? Because it is a broadcast. It is a broadcast message. So when it is a broadcast message, in the B, in the B's transmission range, who are there? For example, A, B, C. A's transmission range is up to B, and C's transmission range is also up to B. But B's transmission range is up to A and B. So B can cover both A and C. So whatever the replies given back by the B will be received by the A and C. So that C came to know that now B is in communication with A. So I don't want to disturb the communication. So I will wait for 10 milliseconds of time. Why? Because the duration of communication is 10 milliseconds. So that even though A is hidden to C and C is hidden to A, because of request to send and clear to send, because of these packets, we can solve the problem like hidden problem. Okay. How can we solve the exposure problem? Exposure also same. In the exposure also, what is the second problem? What is the first problem? A is hidden to C and C is hidden to A. That is the first problem. So likewise, in the second problem, B is willing to communicate to A. B is willing to communicate to A and C is willing to communicate to D. Right? So whenever B is willing to send data to A, it will send the request to send. So in the request to send, what is the sender address? B. What is the receiver address? A. So whenever B is sending the request, it will be known to the C. That why? Because in the request to send, the sender address is B now and the receiver address is A. That means B is willing to communicate with A. So that, okay, C might feel that, okay, B is now communicating with some other node A. So I can communicate with D without any problem. So C is not exposed. C is not exposed to B now. Why? Because in the request to send, it is the B node clearly mentioned that the sender is B and the receiver is A and the duration of communication is 12 milliseconds, for example. Like that, we can solve hidden and exposed problems. Okay, that is about wireless LAN protocol. Okay, that is RTS and CTS. Here the picture is not comfortable, so better you go for some other alternative. If you mention like one by one, it will be clear. The diagram will be clear. If you note down like this, the diagram will be clear. A, B, and then C. So that the explanation will be also easy for you and you can easily, anyone can easily understand. This is the A's transmission range and this is the C's transmission range. If you mention like this now, it will be easily understand by anyone. Easily understandable to anyone, right? And then network layer. So I already told you in the last class, whenever we discuss about one layer, we need to start with the design issues of that particular layer. So what are the design issues of data network layer? So network layer is a lower layer and the transport layer is a above to the network layer. So the services provided to the transport layer. The first responsibility of a network layer is providing services to the transport layer. Okay, that is the first responsibility of network layer. What is the responsibility of a network layer? Network layer responsibility is to provide services to transport layer. Why? Because every below layer has to provide services to the above layer. So network layer is the third layer and the transport layer is the fourth layer. So it is the responsibility of a network layer to provide services to the transport layer. And these services are independent to network size and the router technology. Whatever the services provided the network layer, those services need to be independent to the network size and the router technology. What used in the network, right? And then network layer responsibility is addressing another responsibility, another design issue. And the next design issue is routing. And the next one is the congestion control. All these are the responsibility of a network layer, right? It is a theoretical one. After that, we need to discuss about connectionless and connection oriented service. Before going to discuss about this one, you need to understand this one. So what are the difference between the connection oriented service and what are the differences between the connectionless service? You need to understand this one. So as I told you in the morning session, connection oriented means there should be a communication connection between the sender and the receiver. That means there should be a cable or a wire connection between the sender and the receiver. There are total two types of services. The first one is a connection oriented service. The first one is connection oriented service and the second one is connectionless service. So connection oriented is also called as virtual circuit and connectionless is also called as datagram. So what are the differences between connection oriented and connectionless service? Or virtual circuit versus virtual circuit, short name is VC, and the datagram. Okay, what are the differences between these two? So in the case of connection oriented service, there should be connection establishment. That means setup, circuit setup, connection establishment must be there, needed. If it is a connectionless service, so in between the devices, there is no wire, there is no cable connection. So here setup not needed. That means connection establishment not needed. Setup means connection establishment. Okay. And then coming to addressing. Coming to addressing. So in the case of connection oriented service, there is a number called as VC, virtual circuit number will be there for the connection. As it is a connectionless service, each and every individual can follow their own routes. There is no separate virtual circuit number here. And then what about the state information? So what about the state information? State information means, for example, whenever you want to transfer the data, so just the virtual circuit number will be useful. Here, go to the diagram once, then it will be easy for you. So this is the connection oriented service. If you observe here, follow the cursor. So whenever the packets here, there are 4 packets, 1, 2, 3, 4. If you observe here, all the 4 packets are following the same route. That means once we establish the connection, once we establish the setup or connection, all the particular packets will be forwarded by using a same route. Okay, same connection. Okay, if it is a connectionless service, observe here 3, 2, 1 are going in this particular direction to reach the destination, whereas fourth packet is moving to this direction. That means all the 4 packets are not transferred to the destination in the same direction. Each and every individual packet can go on its way. So there is no connection establishment in the connectionless service. So each and every packet may go in different direction. But in the case of connection oriented service, all the 4 packets are forward in the same direction. That means all the 4 packets are need to be transferred using the same line, same connection setup. Okay. In this direction only, all the packet has to go to reach the destination. Okay. So that means here once we create a virtual connection setup, then automatically there is a virtual connection setup id is there. So in order to pass the packets from sender to receiver, all the packets are transferred by using a same virtual circuit number. Okay. And the next one, for example, if this particular router fail, in the case of connection oriented service, C is failed. If the C is failed, we cannot transfer the packets to destination by using this particular connection. That means if one router fail, we cannot communicate to the destination. Whereas in the case of connectionless service, for example, C is failed, no problem. We can go via B. If there is a problem with C, we can go via B. For example, from Bapatla, you want to go to from Bapatla to Guntur. For example, there is a problem at Konnur. So, in which way you will go? Either you need to go to Chirala, from there Chirala to you may go to Guntur, or you may go to Guntur via Pedanandipadu, right? That is a thing. There is a problem in one route, you can go to the another route. That is like connectionless service. But in the case of connection oriented service, if the follow the cursor, if the router C fail, it is a subnet. Subnet is a combination of routers and the transmission lines. Circles are routers, and these are the transmission lines, right? So all the four packets are following the same direction. For example, if there is any problem with this particular router, this router failed, what happened? So we can move to the another direction. We can move to the another direction in the case of connectionless. But in the case of connection oriented service, all the four packets has to transfer in this particular way only. If C fails, the entire thing fails. But in the case of connectionless service, if C fail, you can go through B. Okay. If one router fail, everything fail. In the case of connection oriented service, again we need to establish the new connection. And next, here all the packets follow the same direction. In the case of connectionless, all the packets can go to their own direction. Okay. That is about the state information. And next, let me explain. All the packets follow the same direction. So if one router fail, communication not possible. We cannot transfer the next packets. Router fail, one router fail, no problem. In the case of connectionless, we can choose another direction in order to transmit the packets. And then here in order delivery possible. In order delivery possible. Here in order delivery not possible. Why? Because after first packet, second packet, and then third packet, and then fourth packet, all are using the same connection in the case of connection oriented. But in the case of connectionless, 1, 2 are transmitting in this direction, and 3 packet is transmitting in this direction to reach the destination. This is another route, and this is another route, right? So 1, 2 are following in one direction, third packet is following another direction. So in-order delivery might not possible in the case of connectionless service. Here the in-order delivery. First the receiver will receive first packet, and then second packet, and then third packet, and then fourth packet. But in the case of connectionless service, in-order delivery is not possible. The receiver may receive third packet first, and then first packet, and then fourth packet, and then second packet. Like that, the receiver may receive the packets not in a order, right? And then connection oriented is a reliable service, and it is not reliable. Connectionless is not reliable. Here the quality of service is achievable. Here the quality of service difficult. Here congestion control is easy. Congestion control. Congestion means collisions. We can control the collisions. Here we cannot control. That means congestion control is difficult. Okay, that those are the differences between connection oriented and connectionless. Now the implementation of connectionless service. Please follow the diagram. on the cursor. For example, process 1 is willing to transfer the information to process 2, which is available in another LAN. So two LANs are the machine in one LAN is willing to transfer the information to the machine in another LAN. Definitely there is a subnet required. A subnet is a combination of routers on the transmission lines. Circles are routers. Here we have 5 routers, A, B, C, D, E. Okay, in the subnet. So initially it is a connectionless service, right? Each and every node need to maintain the table that is called as routing table. So what a routing table consists of? Routing table consists of all the routers information, all the routers information. Okay, and next to, for example, in this particular example, we have total rotors up from A to F. So A, B, C, D, E, F. Okay. For example, A is willing to transfer anything to A hyphen. That is a sender, that is a receiver, right? And next A is willing to transfer the data to B. If A is willing to transfer the data to B, directly A has a communication line. So B to B, A to B, direct communication. If A is willing to communicate to C, directly C. And then if A is willing to communicate to D, either it can go for via B or it can go via for C. So if the destination is D, this is A table, A's table. So A to D, either it can go for B or it can go for C. Now in this particular example, A is willing to communicate to D via B. So B. And then E table. For E, A is willing to communicate to E via C. So C. Or it may go like this. So B, C both are possible. Or A is willing to communicate to F. Either it can go for B via B or it can go for via C. So C and B. This is the A table. What is the C table? C to A. Direct A. C to A, A, A. C to B. C to B means via A. So via A. C to C. So hyphen. C to D. Direct connection D. C to E. Direct connection E. C to F via E. This is C table. What is about E table? E to A via C, E to B via D, E to C direct connection, so C to C, C, and then E to D direct connection, so D to D, D, and next E to D, E to E hyphen, E to F direct connection, so F. Like that, each and every router maintains a routing table. So this is about connectionless. Then what about connection oriented service? As I told you earlier, before going to transfer the packets, the two nodes need to be establish a connection before the data transfer. H1 is willing to transfer the data to H2. Okay. The virtual circuit number is 1, 1, 1, 1, 1. So the first connection number is 1 VC number. So all the packets are following the same route. If you observe here, H1 to 1, that means this is A table. H1 and using the virtual circuit number 1. So whenever A take the incoming packet and it forward to the C and it forward to the C. This is the connection. This is the connection. This is the connection. I repeat, follow the cursor. This is the connection setup. All the packets need to forward the same route. Okay, this is the connection number 1. So whenever A take the incoming packet and it forward to the C via virtual circuit number C. Whenever it is received by, whenever the C receive the information from A, that means this is the first portion is in and the second portion is out. First portion is in and the second portion is out. Check here, A table. A is receiving information from H1. So H1 and then 1. Only observe the first row. Second row is different. Observe the first row. Okay. H1 incoming and then A to C outgoing. A is receiving information from H1 and forward it to the C. A is receiving information from H1 and forward it to C. Now we are in at the C. C is taking the packet from A and forward it to E. C is taking packet from A and forward it to E. Now we are in E. We are at E. E is taking packet from C and forward it to F. E is taking packet from C and forward it to F. Like that, the information is passed to the host 2. Okay. What about the second line? This is another connection. Now H3 is willing to transfer the information to H2. Again, we require a new connection. What is the connection number? 2. Okay. From H3 to A and A to C. H3 to A and A to C. After that, C is taking the information from A and forward it to E. The circuit number is now 2. And then E is taking the packet from C and forward it to F by using a virtual circuit setup 2. Likewise, for example, if any of the process in any of the host willing to transfer the information to the any of the host in another LAN, we need to set up a connection. Okay, no need to maintain a routing table here. Okay, that is about connection oriented service. And these are the differences between virtual circuit and as I told you, effect of router failure. If one router fail, the entire thing is fail in the connectionless. If one router fail, even we can work with the, in the case of connection oriented, if one router fail, entire setup fail. In the case of connectionless, if one router fail, we can go, make use of another route. Okay, router failure is not a problem in connectionless. And next to quality of service. Quality of service is achievable in virtual circuit. Connection oriented, it is easy. Connectionless, it is difficult. Routing. All the four packets choose the same path in the connection oriented. All packets are using different routes, different paths in connectionless. And next, coming to routing algorithms. There are two categories of routing algorithms. One is a non-adaptive algorithm and the second one is a adaptive algorithm. So what is the difference between non-adaptive and adaptive? What is the difference between non-adaptive and adaptive? Non-adaptive and the second one is adaptive. So non-adaptive means also called as static routing algorithms, and adaptive means dynamic routing algorithms. Okay, the routing algorithms are divided into two types: adaptive, non-adaptive. Static means the routing decision is not based on routing table or topology. It not reflect or change based upon the routing table, based or changed on routing tables and topology. Whereas dynamic means the routing decisions are changed based upon the routing decisions are changed. Routing decisions are changed based on routing table and the topology of a network. If it change, automatically topology change, routing table already changed. The routing table change, the decisions are changed in the case of dynamic routing algorithms. So what are the static routing algorithms and what are adaptive routing algorithms? Flooding, shortest path. These two are comes under non-adaptive routing algorithms. Adaptive means distance vector routing or dynamic. Adaptive or dynamic. Under this we have two things: distance vector and the link state. These two are the algorithms under dynamic routing algorithm. Okay. The same thing. And next, what is optimality principle? So optimality principle means it is a subnet with a loop. Observe here, A to B, B to C, C to I to D, and D to A. There is a loop. Okay, A to D, D to H to F to A. There is a loop. And then F to H to E to J to C to B to A. There is a loop, right? A network without loops is called as a sync tree. Network without loops is called as sync tree. Okay, optimality principle states that no loop should be present in transferring the information. So in a network, loop should not be there. Okay, according to the optimality principle, there should not be any loops in a network. A network without loops is called as sync tree. Here there are no links, right? So a network without loops are called as sync tree. And then shortest path routing algorithm. So what is a shortest path routing algorithm? This is the example for shortest path routing algorithm. Each and every node, observe here, each and every node is labeled with two things. What are those? Every node is labeled with distance and distance and the best path to move. What is the best path in order to reach the destination? What is the shortest path in order to reach the destination? In order to know that, we will go for shortest path routing algorithm. So in the case of shortest path routing algorithm, each node is labeled with two things: distance and from the source node along with the best known path. That means here, for example, A to B and A to G. Which one is the shortest in order to move forward? A to B. So what is the length? 2. And what is the source node? A. So 2 comma A. 2 is the distance and A is the source node. Okay. Like that, from I want to transmit the information from A to D. So what is the shortest path? In which direction I want to move? That thing you need to understand. So initially everything will is labeled with dot and the hyphen and the infinity. So this is infinity. Initially we don't know, right? So for A and B, for A, B and G are the neighbors. So A only know about the distance between A to G and distance between A to B. A does not know about the remaining nodes. In which direction I want to transfer the packets in order to reach the destination in a shorter time. A does not know. That is what we need to solve, right? Initially, from A to B, it is 2. A to G, it is 6. Which direction we want to go? In the shortest path direction. So from A to B. So we'll circle this one and circle this one. Fill this one. So 2 comma A. After that, G is not filled. G is not filled yet. Why? Because in order to reach to the G, we may go to this direction and this direction. So 2 plus 2 plus 1, 5. 5 comma E. 5 comma E is the best route. Rather than direct connection between A to G, you can move to A to B and then B to E and then E to G. So 2 plus 2, 4 plus 1, 5. So you can write it here 5 comma E. So because of that reason, I don't want to fill this one right now. So once the packet is reached to B, from B, in which direction you want to go? Either you need to go to C or you need to go to E. Which direction? 2 plus 7 is 9. So you don't want to move to this direction. Whereas 2 plus 2 is 4. So from B to E. From B to E. 2 plus 2, 4. And where the packet is, incoming packet coming from B. So 4 comma B. So now we are at E. After that, for E, we have two neighbors, F and then G. Okay. E to F already 4 and this one 2. 4 to 6. 6 comma B. So 6 comma E. 6 comma E at F. And then what about G? A to G 6, but A to B 2, B to E 2 plus E to G 1. So total 5. So instead of 6 comma a, it is better 5 comma a, 5 comma e. So we fill at G, that is 5 comma e. That means this is the best path. From E, it is the best path to go to G. And then E to F. E to F is E to F 2. Already B to E 4. So 4 plus 2, 6. So 6 comma E. Okay. Once you reach here, so in which direction you want to move? F to C or F to H? F to H is 2, but F to C is 3. So I want to move to F to H. So F to H. So F to H means already if you move F to H, or you can move to G to H. Which one is a better? So for G, at G 5 comma E, 5 plus 4 is 9, 9 comma G, 9 comma G, or if you choose F in this direction from F to H, F is 6 and 6 plus 2 is 8. So 8 comma F, 8 comma F or 9 comma G, which one is better? So 8 comma F is the shortest one and compared to G comma 9 comma G. So 8 comma F is better. So after that from here we move to this D. That means 2, 8 plus 2 is 10, 10 comma H is the last one. Like that we will find out the shortest path. So each and every node is labeled with distance, we don't know, infinity and the hyphen. Actually this is the distance and this is the source path. Okay, from A to B the distance is 2 and the source is A. From B to E the distance is again 2, so 2 plus 2 is 4 comma B, 4 comma B, so 4 comma B. And then from E to F, E to F is 2, so 6, then coming is E, so 6 comma E. After that, you can move to the H. H has two incoming paths. In which one is the best one? If you move from F to H, it will be 8 comma F. If you choose a G path, it will be 9 comma G. 9 comma G is not better than 8 comma F. So that is the reason why you will choose 8 comma F. From 8 comma F to D. D means 2. So total 10 comma H. Likewise, we will choose the shortest path. And the next routing algorithm is flooding. What is a flooding? So flooding means only concentrate on the highlighted lines. Every incoming packet is sent out on every outgoing line except the one coming. That means whenever the packet we want to transfer, the packet will be transferred to the all the neighbors in all the directions except the one it is coming, and the incoming packet is forward to the all the directions except the one, except the incoming route. It will forward to the all the remaining directions. And next, because of that reason flooding generates so many duplicate packets. So in order to avoid so many duplicate packets, so what will you do? You will introduce the concept called as hop counter. Hop count. What is a hop count? Initially the hop counter will be set to the length of the path from source to destination. Okay, so let me explain with the help of a paint. Here if you observe, this is a node, this is another node, this is another node, this is another node, and this is another node, and this is. So for example, this is the network. So whenever a packet A, B, C, D, E, F, F, G, right? So what happened here is whenever a packet A want to transfer the packet, it will forward the packet to all the directions. So it will forward a packet to the B and C. Whenever B receives the packet, what it will do? It will forward the packet to this node, and this node. So what this will do? Whenever a packet coming from this direction, Except this direction, it will forward the package to this direction. Except this, yes, except this route, it will forward this to this. Again, whenever there is a packet coming from B, the D node will forward the package to this direction, this direction. Already B forward the same packet here. Again F, whenever the packet coming from this direction, F will forward the packet to this direction. The screen. Okay, thank you. Right? Likewise, each and every incoming packet is again forwarded to the remaining nodes. Okay, okay. Likewise, each and every node, whenever there is an incoming packet, that incoming packet is forwarded in all directions. This node will forward the packet in this direction, and this node will forward the packet to this direction, this direction, this direction again. So there will be a lot of duplicate packets. Okay. In the case of flooding, there is a chance of duplicate packets. In order to avoid these duplicate packets and looping, so what can we do? The solution is hop count. What is hop count? So what is the length, the number of hops in order to reach the source from destination? If it is a destination, this is a source. One hop, two hops, three hops. Or in this direction, one hop, two hop, three hops. If you move to this direction, one, two, three, four. Hop means distance between the link. Hop is nothing but a link. Okay, that hop count will be used to avoid the duplicates and looping problem. So whenever a packet is forwarded to this direction, to the next node, automatically the hop count will be decremented by 1. Hop count minus 1. Whenever the packet is reached from this direction to this direction, again the hop count will be decremented by 1. Whenever it is decremented from this direction to this direction, again the hop count again decremented by 1. Like that, it finally reached to 0. That means after 3 hops, it will be automatically become 0. So whenever the hop count will be 0, then the packet will not be forwarded again in the network. So by like that, we can avoid the duplicates. Okay, we can avoid the looping. Sorry, looping problem will be avoided with the help of hop count. How can we avoid the duplicate? For example, if it is a network, this is our network, right? So whenever a packet is transferred from A to B and C, again B will forward the same packet to C again. A already forward the packet P1 to B, and B is also forwarding the same packet to C. So there is a duplicate packet at C, right? In order to avoid that problem, we can use a sequence number concept. Okay, whenever the particular C node will get the same packet from different source, automatically what it will do? It will discard the packet. Why? Because it will consider it as a duplicate one, and it will discard the packet. Have you got my point? So Likewise, with the help of hop counter and the sequence number, we can avoid duplicate problem and the looping problem. The variation in the flooding is selective flooding, right? The selective flooding is a variation of flooding. In the selective flooding algorithm, the routers do not send every incoming packet out on every line. Only those lines that are going approximately in the right direction. That means whenever you are sending a packet to the whenever you are sending a packet to the next node, for example, consider here in this particular example, whenever B receives a packet from A, okay, so the destination is G, right? So the packet need to be forwarded in this direction, okay. There is no need of forwarding the packet to this direction. That means the router will only select the best possible lines, select only few lines, few right lines to forward the packet to the next nodes. That is called as selective flooding. So these two are comes under non-adaptive. Static algorithm, shortest path routing algorithm, and the next one is a flooding algorithm. So now coming to dynamic algorithm. Under the dynamic algorithm, we have two things: distance vector routing algorithm and the link state routing algorithm. Before going to discuss about those things, hierarchical routing and multicast routing are also there, but these are not there in your syllabus, I think. But otherwise, I will let you know. Okay, hierarchical routing means here, if you observe, there are 17 nodes in this particular entire network. 17 nodes: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17, total 17 number of nodes. Okay, each and every node need to maintain the routing table. Each and every node maintain the routing table. Hierarchical routing is, in the hierarchical routing, each and every node maintain the routing table. So what is the routing table for 1A? 1A has to maintain the routing table with 17 entries. Why? Because 1A to 1A, 1A to 1B, and 1A to 1C, 1A to 1D, so 1A to 2A, 1A to 2B, 1A to 3C, like that, each from 1A to all the remaining nodes. What is the distance? What are the number of hops required? Like that, each and every node maintains the routing table. Every node, every router, 1A has to maintain one routing table, 1B has to maintain one routing table, okay, 1C has to maintain one routing table. Each routing table, how many entries are there? 17. Why? Because in this example we have total 17 number of routers. So we need to maintain the routing table. What it contains? 1A to 1A hyphen hyphen, 1A to 1B. What is the path? Direct 1A can go to 1B. There is a direct connection. And 1A to 2A maybe. 1A to 2A. Check 1A to 2A. 1A to 2A via 1B. What is the hop count to? 1A to 2A. Follow the cursor. 1A to 2A. Number of hops. A to 1A to 1B, 1 hop. 1B to 2A, 1 hop. Total 2 hops. So in order to move from 1A to 2A via 1B, the number of hops is 2. Okay. So we need to reduce the routing table size. If the entries are more, the routers are more, the number of entries are also more. In order to avoid such a problem, we'll divide the network into regions. Region 1, region 2, region 3. So that instead of maintaining the 17 entries, we can make only 7 entries. So region 1, 1A, 1B, 1C. 1A, 1B, 1C. For entire region 2. For entire region 3, only 3. For entire region 4, only 4. For entire region 5, only 5. 1A to 1A. What is the distance? 0. Hop. Outgoing line also 0. So 1A to 1B means there is a direct connection and 1 hop. 1A to 1B, 1 hop. 1A to 1C, 1 hop. And then 1A to 2, entire 2, via 1B, 2. And next 1A to 3, via 1A, 1 via 1C, 1, 2. So via 1C, 2. And next to for region 4. via 1C, number of hops 1, 2, and then 3. So 3. So for region 4, via 1C, 1, 2, 3, 4. Or you can go via 1B also for region 2. 1, 2, 3, 4, and then 5. In this direction, 1, 2, 3, 4. Because of that reason, we are moving via 1C. Likewise, we can reduce the routing table size. The hierarchical is not, routing is nothing but the entire network is divided into regions. So there is only one entry in the routing table. There is only one entry for region in routing table. And the next one is a multicasting. Multicasting means one to many. This is the routing table. This is the network. So here we have a loops, right? Here we have loops. So we need to maintain a sync tree. Sync tree. So this is a sync tree. Why? Because there is no loop. There are no loops here. So the first one is a network, given network. From this network, you need to draw the sync tree or a spanning tree without loops. After that, if we observe here, there are two categories of nodes, 1 and 2. Whenever you want to send a message to one, that message is sent to only one group. Whenever you want to send a message to the second group, that message is only received by the two, not one. That is called as multicasting. Only one where the ones are present here, here, and then here. There is no one. So up to this point, okay. And then in this direction, up here, there is no one, there is no one. So up to here only. And here there is a last one. So we move to last one, right? Whereas coming to two, second group. So from here to here only. No need to go further. Why? Because there is no two afterwards. And then in this direction, here, here, and here. So we need to go to this one. Okay. This is for only two, and this is for message is only for one, and message is only for two. That is called as multicasting. Sending a message to a group of nodes only, not all the nodes. And the next one is a distance vector routing algorithm. In the case of distance vector routing algorithm, as the name indicates, each and every router has to maintain a routing algorithm, routing table. Okay. Another name for the distance vector routing algorithm is Bellman-Ford or fold-Fulkerson algorithm. In your question paper, Bellman-Ford or fold-Fulkerson or distance vector routing algorithm, all the three are same. Shortest path routing algorithm, Dijkstra algorithm, both are same. So this network, so this is the network. So it consists, this will, it will get, you will get this particular network in the examination paper, as well as you will get this information, four tables. These are the routing table of, this is the routing table of A, this is the routing table of I, and this is the routing table of H, and this is the routing table of K. Okay. So these four information and this is network you will get in the examination. Based upon these two information, you need to draw the routing table. Okay. So A to A, how many number of nodes are there? From A to L. So each and every node maintains a routing table, A to L, A to L entries. For I to A, I to B, I to C. This is the distance. A to A 0, A to B 12, A to C 25, A to D 40. Like that, these are the distances and these are the number of routers in the network. Like that, you have the routing table for A, I, H, and K. Now you need to find out the routing table for J. Routing table for J. Already we have a routing table for I, we have a routing table of K, we have a routing table of H, we have a routing table of A. What are the neighbors for J? J neighbors. Neighbor means direct communication from J. J to I, J to K, J to H, and J to A. There are direct links. So all those four are neighbors to J. Based upon the routing tables of I, H, A, K, we need to construct the routing table for J. So here they will give some details. J to A 8 and J to I 10, J to H 12, and J to K 6. That means J to A. What is the delay? 8. We know that. J to I. What is the delay? 10. We know that. And J to H. What is the delay? 12. And J to K. What is the delay? 6. So 8 J to A, and then J to I. J to I. Where is J to I? J to I. J to I. 10. And then J to H. J to H. 12. 12. And J to K. 6. Those information they are already given. Then what about J to B? Now you need to calculate J to B. I will give you clue for J to B and J to C. Remaining you have to do. How can we calculate the delay between J to B? Okay. Initially we know that J to A. What is the length? J to A is 8. From what is the distance between A to B? 12. So in order to go to B via A, what is the length? J to A is 8 and A to B is 12. A to B is 12 and J to A is 8. 8 plus 12 is 20. Via A 20. What is about via I? J to I is 10 and then I to B. I to B. I to B 36. 36 plus 10 46. Via I 46. Via A 20. Then what about via H? J to H is 12 and H to B is 31. 31 plus 12 43. Okay, 43 and then this 36 and then this is 20. What about J to B via K? J to K 6 and then K to B 28. 28 plus 6 34. So among these four, which one is the shortest? J to B via A 20. So J to B via A 20. Okay. Then what about J to C? What about J to C? So again we need to go either from A or from I or from K or from H. Which path we need to go? Right? J to A 8 and A to C 25. 25 plus 8 33. Okay. J to I 10 and then I to C 18. 18 plus 10 28. So 28 35. 28 is smaller. And then H. J to H is 12. And then H to C 19. 19 plus 12 31. Okay. And then J to K. J to K is 6. K to C is 36. 36 plus C is 42. So among all those things, so H is the best path to reach the C. So J to C, J to C via I 28. 28 is the shortest, right? J to H is 31. So this is the 28. So 28 is the shortest one. Likewise, we need to construct the J routing table. So this is called as distance vector routing table. So based upon the routing tables of the neighbors, we can calculate the best path to reach the destination. So this is distance vector routing algorithm. So I will discuss this count to infinity problem. So there is a problem with distance vector routing algorithm, that is in count to infinity. So what is count to infinity? For example, initially every node is willing to transfer the information to E. So initially they don't know what is the distance. So whenever A want to transmit the packet to B, the distance between A to B is 1 hop. So 1. Everyone is willing to transfer the information to one node. So here in this example, A is willing to transfer the information to B. So what is the distance? 1. And then B to A is 1. And then based upon the B, C thinks that I want to transfer to A. So what is the way to transfer to A? I don't know. But from B to A, it is 1. So from me to B, it is 1. So 1 plus 1 is 2. So based upon the B's information, C change it to 2. So D also don't know, initially don't know how to reach the A. But based upon the C's information, D think that from me to C it is 1 hop distance, from C to A it is 2 hop distance. So 2 plus 1 is 3. So I can reach the A with 3 hops, so that it will update the table. Based upon this information, E think that okay, I cannot have a direct route to A, so I need to follow the D. So what is the distance between D to A? It is 3 hops. So from E to D, it is 1 hop. So 1 plus 3 is 4. So E might think that I can exchange information to A within 4 hops. What D think that I can exchange information to A with 3 hops. See what C think that I can reach A within 2 hops. What B thinks I can reach A with 1 hop. Like that, after 4 exchanges, I can transfer the information from E to A. This is the good news. So what about this one? Initially B 1, 2, 3, 4, right? Initially all 1, 2, 3, 4. Why? Because from B to A 1 hop, C to A 2 hop, D to A 3 hop, E to A 4 hops, 1, 2, 3, 4. So what happened suddenly? There is a link problem here. There is a communication link problem from B to A. So then immediately B will check the other direction. So B will check the C. What C indicates? From C to A, it indicates it is a 2 hop distance. Based upon its information, B will change the value to 3. Or you got my point? There is a connection failure from A to B. So based upon the C's information, B is change the value from 1 to 3. Why? Because B to C is 1 and C to A is 2. Like that, B think that there is another route from a C to reach A. There is another route from C to reach A. So B think like that, and it will change the value to 3. Whenever B change the value to 3, immediately C change the value to 4. Why? Because from B to A 3, and then C to be 1, 3, 4. Immediately whenever C change the value to 4, immediately B also change its value to 5. Whenever B value change value to 5, again it will change value to 6. Whenever it change the value to 6, like that, based upon the values, continuously B change based upon the C value, and C change the based upon B value. And based upon the C value, D change its value. Based upon D value, E change its value. Like infinity time. So and actually the thing is, entire these values are everything is wrong. Why? Because actually there is no connection from A to B. If there is no connection from A to B, how can C the transfer information to A? C also want to transfer information via B, and C also want to transfer the information to via C, and E also want to transfer the information via D. So like that, each and every node is depending upon the routing table information of other nodes. So this is the problem in distance vector routing table, count to infinity problem. And the next one is a link state routing algorithm. So what is link state routing algorithm? So here the link state routing algorithm is based upon the 5 steps. Discover the neighbors, and then measure the delay, construct the packet, distribute the packet, compute the shortest path. So these are the 5 steps. What are those? First, learning the neighbors. What are the neighbors? A is a direct connection to A, C, F are neighbors. That is the reason why N. A is connected to this LAN, and C is also connected to this LAN, and F is also connected to this LAN. This one is changed like this in order to know the neighbors. So direct connection, right? First we need to know the neighbors by using a hello packet. Each and every neighbor, for each and every neighbor, we need to send the hello packet. Hello packet is used to identify the neighbor. After that, what you need to do? Measuring the line cost. We need to identify the cost. How can we measuring the cost? By using a echo packet. So whatever the distance between Bapatla to Pannur, the Pannur to Bapatla is the same distance, right? Echo is used to calculate the same. Echo is used to calculate the distance between the two nodes. Whenever you send a message, it will take 1 second of time. And, and at the same time, whenever you return back the information from that particular node, acknowledgement, again it will take the 1 second of time. Okay, based upon such a technique, we can calculate the cost between the link cost between the two nodes. By using echo, we can get the time, how much it takes to transfer a packet from one node to the neighbor node. After that, we need to construct the link state. What are the first step? We need to discover the neighbors. After that, we need to calculate the cost. After that, we need to construct the packets. How can we construct the packets? For example, A, what is the neighbor B and E? So this is the A packet. A, B and E. What is the distance between A to B? 4. What is the distance between A to C, A to E? 5. For B, A is one neighbor, C is one neighbor, and F is one neighbor. So A, C, F. What is the distance? 4 to 6. 4 to 6. Likewise, we need to construct the packets. Once we construct the packets, each and every packet contains the sequence number. And then we need to distribute the packets. Distribution is done using the flooding. Okay, we will flood the packets. Okay, if there is any duplicate packets based upon the sequence number, we can discard the packets. The routers may discard the packets based upon the sequence number. And then computing the new routes based upon the shortest path, we need to forward the packets. That is about link state algorithm. What are the steps? 5 steps. We need to discover the neighbors. Hello packet is used to discover the neighbors, and then echo is used to identify the delay between the neighbors. And then we need to construct the packets. What a packet consists of? A packet consists of sequence number, A's, and the neighbors of that particular node. What is the distance between the neighbors? The entire information is available in the packet. So once we consider the packet, you need to send the packet. How can we send the packet to all the other nodes? By using the broadcast mechanism. In order to avoid the duplicate number, so we include the sequence number in the packet, and then compute the shortest path to every router. It's based upon the information. So the routing information, that whatever the packet you constructed, that packet is distributed to all the nodes in a router, right? So each and every router has an idea about the remaining routers now. So we can find out the shortest path in order to transfer the packet from one node to another node. That is about link state routing algorithm. So this is the end of your network layer. And then we need to talk about congestion control. So what is congestion control? What is congestion control? Congestion control means too many packets into a network leads to the congestion. Congestion is like traffic jam in real time. Too many vehicles on the main road causes the traffic jam. Likewise, too many packets into network causes congestion. What the congestion will lead? The congestion leads the collisions. In order to avoid such a problem, there are, observe this diagram. The packets delivered, if more packets are delivered through a network, initially the network performance will be increased. If number of packets are increased, so if you send more number of packets through a network, initially the graph will be like this. So after reaching to the certain point, so you cannot send beyond that level. You cannot send more than this level. Why? Because too many packets enter into the network, so that it may lead to the congestion, so that the network performance will be reduced because of collision. Initially you are sending one packet, okay, successful. You increase it to 2, you increase it to 4, you increase it to 8, you increase it to 16. Likewise, you are increasing the number of packets in a network. So at some point, what happened? So these packets might collide with the other packets. So there will be a congestion. So whenever there is a congestion, what you will do? You will reduce the number of packets. Whenever there is a congestion, automatically you stop sending the vehicles to that particular route, right? Here also in the network, whenever there is a congestion, you stop sending the packets to the network to reduce the number. Still you got the collision. Again you will reduce the number. Likewise, after some time, the packet delivery ratio will be reduced. Packet sent will be decreased, right? General principles of congestion control. There are two types of principles. They are categorized into two things. One is open loop and the second one is a closed loop. Closed loop is also called as feedback loop. So what is open loop and what is closed loop? Open loop is called as initially before going to happen a congestion. So what you need to do is you need to construct the virtual circuit. Whenever you create a connection establishment, at the time of connection itself you need to design a very good network so that there will be no collisions. Okay, that is called as open loop. Open loop means it won't excuse us and it won't allow us to do the modifications once the network design is done. So while you are constructing the network itself, while you are designing the network itself, you need to take care of the very good network design. If you have very good network design, then the congestions will be low. Okay, that is what open loop. Then what about the closed loop? Closed loop means we need to monitor the system whenever there is a collision or whenever there is a congestion. So immediately you need to monitor the network and then you need to identify the congestion or collisions. If there is any congestion found, you need to take the corrective measures. That is called as closed loop. What is open loop? What is closed loop? In the case of open loop, while you are constructing the network itself, you need to go for a good network design. No further modifications are allowed. Whereas in coming to closed loop, so you need to monitor the entire network for time to time. So if there is any congestion or collision found, immediately you need to identify that one and you need to take the corrective measures. You need to adjust the system in order to correct the problem. Okay, that is about closed loop. And then congestion prevention policies. So at each and every layer we have some policies. So data link layer, network layer and the transport layer. These three layers we have some congestion prevention policies. How can we prevent the congestion? At the data link layer, retransmission policy. So there are two types of retransmissions. One is go back and the second one is a select to repeat. Which one you have to choose? You have to choose select to repeat. If you choose select to repeat, if there is any damage or lost frame, what you will do? Will retransmit only the damaged frame, not the all the frames. But whereas in the go back end, so we need to retransmit all the frames after the last frame. So that is the reason why we need to choose the selective repeat. And then out of order caching policy. So out of order means here there are two types of things: connection oriented, connectionless, right? Out of order means you need to follow the sequence number. If you give the correct sequence number whenever it reaches to the destination, so based upon the sequence number, the receiver will take them in the arrange them in the order and will forward to the network layer. And the acknowledgement policy. Acknowledgement policy means here we need to follow the piggybacking. In the morning session, I didn't cover the piggybacking. What is piggybacking? The sender will send a packet to the receiver. Upon receiving a packet, the sender will send back the acknowledgement. Okay. So now what is piggybacking is along with the acknowledgement, the receiver can send some data to the sender. That means data plus acknowledgement will be sent back from the receiver to the sender so that the network bandwidth will be utilized in a better fashion. Why? Because receiver is also willing to send some data to the sender. At that time, if we send data and acknowledgement separately, we need to send the data separately and we need to send the acknowledgement separately. So it is a wastage of bandwidth and time. In order to avoid such situation, what you have to do? We need to combine data and acknowledgement into one pack and we need to transfer the pack to the node sender. Okay, and next flow control. Flow control means fast sender, slow receiver. Okay, whenever the receiver is unable to receive the information, the sender has to slow down based upon the receiver. Okay, sender not continuously send the message. The sender has to wait until the packet is or frame is received by the receiver. If the receiver is not able to receive the information, then immediately sender has to slow down the transmission rate. And the next one is a network layer. So virtual circuit and the datagram. In the network layer, we need to have an idea about we need to talk about connection oriented and connectionless. So a connection oriented service is best among the one. Why? Because connection oriented is reliable service, guarantee delivery. So there is no need to retransmit the packets again and again. And the next, packet queuing and service policy, right? So whenever there is a incoming router has to maintain the packets in the routing buffer. So whenever there is no congestion, router will take the packets from his router queue and then forward to the next router. Are you got my point? Each and every router has to maintain a queue. So whenever there are incoming packets coming to the router keep that particular incoming packets into the router queue. Okay. When there is no congestion, the router will take the packets from the queue and it will forward to the destination via other routers. And next, packet discards policy. So whenever there is a congestion, we need to prioritize the packets. So we need to forward only high priority packets when compared to the low priority process. Why? Because if there is a congestion in network, better to forward in emergency packet. For example, if there is a traffic jam, so all the vehicles are not allowed to go further, but we are giving a chance to the ambulance. Why? Ambulance is a high priority vehicle. Even in the traffic jam also, we are giving much priority to the ambulance, right? Such a fashion, we are categorize the packets into high priority and low priority. We need to give high priority packets the first chance to go to the destination. That means the router has to choose the high priority packets. Those packets are only transferred to the destination in the case of congestion. And the next one is a routing algorithm. We need to choose the best routing algorithm in order to transfer the packets to the destination in a fast manner. And next, packet lifetime. How much time a packet can live into the network? So it should not be too high, it should not be too low. If it is too high, the packet is within the network much time, so it creates a problem, collision. If it is too short, the packet may not reach the destination. That is the reason why it need to be medium. And the next one is transport layer. So retransmission policy, these are all these are same except this flow control, the timeout determination. Timeout determination means how much time it takes to transfer a packet from source node to destination node. It is not too high, it is not too low. If it is too high, the delay will be more. The time it takes to transfer a packet from source to destination is more. If it is too short, the packet may not reach the destination. So the time to transfer the packet from source to destination need to be not too high, not too low. It need to be minimum. Those are about congestion prevention policies. Very important question. General principles of congestion control. Under it, you need to write about open loop and closed loop. After that, under congestion prevention policies, you need to write about the policy at data link layer, network layer, and transport layer. So after that, what is traffic shaping? Traffic shaping nothing but regulating the average rate of data transmission. That means if you regulate the data transfer, automatically the congestion will be low. If you regulate the vehicle flow in a traffic, the traffic police will regulate the traffic. How can they regulate? They will regulate the traffic by stopping the vehicles not to go continuously. Okay. Few times they will say give you the red signal, so some vehicles will be stopped there. After some time, they are allowed to go. Likewise, here traffic shaping means we need to regulate the speed of data delivery. Average rate of data transmission need to be regulated so that it will be reduce the congestion, so that number of packets we can transfer to the destination without any collision. Okay. What is traffic policy? Traffic policy means monitoring the traffic. So what are the techniques we have under traffic shaping? Leaky bucket and the token bucket. So what is leaky bucket? So whenever there is a water leakage at the bucket, so the water will be dipped out of the hole, right? So likewise, the host computer is injecting packets to the network. Whenever the host computer injecting the packet to the network, so what you have to do? Computer is computer will send the packets. The machine is continuously send the packets to the network, inject the packets to the network, but the network is unable to handle the incoming packets. It cannot forward the packets to the next router. So what it has to do, we need to regulate the flow. So how can we regulate the flow? Here is a leaky bucket. So whatever the packets injected by the computer will be forwarded by the will be forwarded or will be taken by the leaky bucket. From a leaky bucket, only one packet is forwarded to the or injected to the network. Likewise, from host computer to leaky bucket, this is unregulated flow. From the leaky bucket to the network, it is a regulated flow. That means here the computer will continuously send the packets without any regulation to the leaky bucket. But from the leaky bucket, only packets are injected to the network in a regulated flow. Only one packet. So what is the problem here? We can regulate the network flow, but what the problem is, if the more number of packets are injected to the leaky bucket, there is a chance of, even the network is free also, the leaky bucket will send only one packet into the network, so that the delay will be more, and most of the packets are dropped at the leaky bucket. Why? Because from the leaky bucket only one packet are we are injected to the network, but more number of packets are coming to the leaky bucket, and only one packet is injected to the network. So at some point of time, there will be a overflow at the leaky bucket. In order to avoid this problem, we'll go to the token bucket. So here also the computer will send the packets to the token bucket. If we observe here, how many number of tokens are there? Dots. 1, 2, 3. Follow the cursor. Follow the cursor. How many number of dots are here? These dots are called as tokens. 1, 2, 3. If there are 3 tokens are available, so we can forward or we can inject 3 packets at a time to the network. If we forward 3 packets to the network, what are the number of tokens? 0. So every delta t seconds, there is a token generated to the leaky bucket, token bucket. For every delta t second, there is a token generated, and based upon the number of tokens, that many number of packets. If we here in this example, we have 3 tokens available, so we can inject 3 packets into the network. Likewise, based upon the number of tokens, we can inject more number of packets in network. What about the leaky bucket? We need to inject only one packet to the network at a time. Packet by packet. Okay, but here the flow is very high flow. That means more number of packets are coming to the leaky bucket, but only one packet is going out to the network. That is the problem with leaky bucket. So there is a chance of leakage at the leaky bucket. The packets may be overflow at the leaky bucket. In order to avoid such a problem, we'll go for the token bucket. The token bucket consists of tokens. For every delta t seconds, there will be a token added to the token bucket. Based upon the number of tokens, that many number of packets we can inject directly to the network. Here in this example, we have 3 tokens available in the token bucket. So we can inject 3 packets into the network, right? So before, after. So 3 packets are injected. So there is no token available, right? For every delta c seconds, the token will be added to the token bucket, right? And then congestion control. How can we control the congestion? Follow the red lines in the virtual circuit. As I told you earlier, so virtual circuit means we need to set up the connection first and then data transfer. So first we need to establish the connection. So by using that connection, all the data packets are transferred to the destination. So in the help of virtual circuit, we can control the congestion by using the admission control. Admission control means whenever you establish a connection, at the time itself, you need to check for the complexity. If there is a chance of congestion, you should not allow to allow for a new connection setup, right? If there is already a congestion in a network, at that time, if any host want to transfer a packet to any other host, it may ask you to create the connection. You should, at that time, you should not create a new connection. If there is a already problem with the network congestion, you should not create a new connection at the time of congestion. Okay, and you need to carefully identify the problem areas where the congestion occurs. Whenever you route the packets, you the same route you should not use to transfer the same route you should not use for transferring the upcoming packets. Okay, if there is a congestion, you need to avoid the congested area. You need to choose some other path in order to transfer the packets from source to destination. You need to choose some other path. If there is a collision at one path in a network, you need to choose some other path for data transmission. Okay, that is the thing. And next, whenever there is a communication between the two hosts, there should be some agreement between the host and subnet. What is it? What is the volume? What is the shape of the traffic? What is the quality of service required? What are the other parameters required for the communication? Those things need to be discussed. There should be an agreement between the host and subnet. Based on that only, the connection need to be set up. And the next one, congestion control in datagram. Congestion control in the datagram means there is a warning bit. For example, if there is any congestion at one place, from that place to sender, there is a warning bit. So whenever there is as an acknowledgement, so what the sender will do, whenever there is a warning bit, automatically sender will reduce the speed of transmission rate. For example, now the sender is sending 8 packets. Okay, there is a congestion, so the warning bit will be sent back to the sender. Okay, that is called as a back pressure. Okay, whenever there is a warning bit, the sender will reduce the transmission rate to 4, 8 to 4, reduce the transmission rate from 8 to 4. So again there is a warning bit, so again what the sender will do, the sender will reduce the transmission rate from 4 to 2. Likewise, the sender will reduce the transmission rate whenever there is a warning bit. Once there is no warning bit, again the sender will increase the transmission rate from 2 to 4 and then 4 to 8. Likewise, whenever there is a warning bit, the sender automatically decrease the speed of transmission rate, and whenever there is no warning bit, the sender again increase the transmission rate exponentially. Right? And the next one is a choke packet and hop by hop packets, load shedding and jitter control. So let me explain this one so that I will wind up the session within 5 minutes. Not a problem. Right? So what is a hop by hop choke packet and then choke packet? So for example, if there is a network from A to B and B to C and C to D and D to E, E is the destination. So initially what happened? Warning bit already I told you. I talk about choke packet now. So what is choke packet? With the help of choke packet, whenever the sender is sending something, the sender will send the packet to B. B will forward the packet to C, and C will forward the packet to D. D will forward the packet to E. If there is any congestion happen, then what will E packet will do? E will send the choke packet. There is a congestion, so please regulate the flow of transmission. So that will be forwarded to D, and it will be forwarded to B, and then it will be forwarded to A. So whenever the choke packet is received by A, at that time A will reduce the flow. Up to that point, A will continue with the same flow. A will continue with the same flow. This dark line, same flow. Right? This is called as choke point. So whenever he receives the choke, at that time A will reduce the speed. That is about choke. What is hop by hop? Hop by hop is this is A and this is B and this is C router and this is D and this is E. What is hop by hop? Initially, A is sending the data with this speed. with this transmission speed, dark line. Okay, so whenever there is a choke packet coming from E, what D will do? D will forward the choke packet to C, and it will reduce the size. Let me use the right. Whenever there is a choke packet from E to D, immediately D will reduce the flow like this and forward the choke packet to C. What the C will do? Whenever the C receives the choke packet, C will regulate the flow. It will reduce the flow, and then it forward the packets to the and it will forward the choke packet to B. Then what will do? Immediately B will reduce the flow and forward the choke packet to A. Whenever A receives the packet, A also regulate the flow. That means it will also reduce the flow. Likewise, what is the difference between these two? In this particular one, whenever whenever E is send back the choke packet to D, D is continue with the same flow. C also continue with the same flow. B also continue with the same flow. A also continue with the same flow. Whenever the choke packet reach to the A, then only the flow will be reduced. But in the case of even congestion happened at this point, recognized at this point, but even A is continuously sending the data with the same speed until the choke packet reach to the A. But here, whenever there is a congestion, so I cannot receive the information sent by you. That thing will be delivered by E to D. Immediately, D will reduce the speed and then forward the choke packet to C. Whenever C receive the choke packet, it will regulate the flow from here at least, and then send back the choke packet to B. Whenever there is a choke packet received by B, then B also reduce the flow. After that, B send the choke packet to A. At that time, A also regulate the flow. Likewise, whenever a intermediate node receives the choke packet from the previous node, immediately it reduce the speed. That is the difference between choke packet and hop by hop choke. Okay, and the next one is the load shedding. What is load shedding? Each and every router maintains a buffer, right? So whenever there is an incoming packet to the router has to take the incoming packet and forward it to the next router in order to reach to the destination. The router takes the incoming packet and forward it to the destination via the outgoing line. So whenever there are incoming packet, the router will prioritize the packets. Priority. Based upon the priority, high priority packets will be transferred to the next nodes in order to reach the destination. Low priority packets will be discarded. If there is any congestion, we need to reduce the congestion, right? How can we reduce the congestion? We need to reduce the number of packets flow in the network. How can we reduce the number of packets? With the help of load shedding. The high priority packets will be only transferred to the destination. The low priority packets will be discarded. Why? Because there is no emergency of low priority process, but high priority packets need to be delivered to the destination. Even though, as I told you earlier, the ambulance, even though there is a traffic jam, ambulance need to be reach the hospital on time. For that purpose, even though there is a congestion, there is a traffic jam, so we will provide the way to the ambulance. Likewise, here also, even though if there is a network congestion in the network, we are giving a priority to the some packets. So those high priority process will be forwarded by the routers rather than the low priority process. That is called as load shedding. And then what about the jitter control? The last one. What about the jitter control? Very important one mark question. Jitter control. So what is jitter control? Difference in arrival time. Difference in difference in arrival time is called jitter. Difference in packet arrival time. Sorry. Difference in packet arrival time is called as jitter. Okay. For example, you are sending 4 packets. Packet 1, packet 2, packet 3, and packet 4. So all the 4 packets will take 2 milliseconds of time to reach the destination. This is the transfer time, TR. Okay. So at that time, so second packet will be reached to the destination at 8 o'clock, and the second packet 2 is reached to the destination at 8:1, and packet 3 will be reached to the destination at 8:4, and packet 4 is reached to the destination at 8:6. So there are difference in time, right? So even though all the packets consumes 2 milliseconds of time, so each and every packet takes different times. So this is called as the difference in arrival time is called as jitter. Okay. Right, what is a jitter? Follow the cursor. If we are sending a audio or video at constant rate in quality, if you are sending audio or video, so what we require, we need to have a very good high quality. So the variations in packet arrival time are called jitter. So automatically there is a difference in arrival time, so automatically the quality will be reduced, quality of the audio as well as video will be reduced. So when a packet arrives at the router has to check how much the packet is behind or how much the packet is ahead. That means in sometimes the bus need to be arrived to the Guntur bus stop by 8 o'clock. And sometimes it will be reached to the destination by 7:50. That means it is ahead. Sometimes the bus has to reach at 8 o'clock. It will be reached to the destination around 8:10. That means it is behind. So the router has to check whether the packet is arrived, reached to the schedule, is on behind schedule or ahead schedule, right? The packets that are ahead need to be slow down. The packets are behind, they need to speed up. So the same policy, the APR, our transportation, all the buses in our state will follow the same rule. For example, the bus has to reach to the bus station by 8 o'clock. So the driver will uh, go in a speed manner. So the bus is able to reach the destination before 8 o'clock. That means 7:50. It should not reach the bus stand before time. So what the driver will do? The driver will take you to the Guntur in around 7:45, and then he will take much time to reach to the destination. Why he will go slow from that particular moment to bus stop? Why? Because she need to be there on time, should not be go behind the time. He should not reach the destination ahead. So because of that reason, what the driver will do? The driver will do the compensation. If he go fast initially, then what he will do at the end? He will go slowly, right? For example, it takes much time for the driver because of the traffic and all. He couldn't make it possible, so he will reach the destination at. You need to reach the destination at 8 o'clock, but already he takes much time due to the traffic jam and all. So what he will do, once the traffic jam is over na, immediately he will speed up his driving, and he will reach the destination at 8 o'clock, right? Likewise, the router will check the packets, whether the packets in the network are ahead the schedule or behind the schedule. So if the packets are ahead, then automatically the router will slow down transmitting the packets. If the packets are behind, then immediately the router will forward the packets to the destination in a faster manner. That is about the congestion control in datagram. Okay. So in the next class, it will take 1 hour time for me. Might take 1 hour time to complete the remaining syllabus. So as you are only 5, of course, not a problem. So even if we are one participant also, I don't have any objection.